Welcome to this first lecture of quantitative analysis. We are going to start by taking a look at what we mean by data. When we are thinking of the scientific method, it's just the evidence you need to arrive at knowledge. So data consists of information coming from observations, counts, measurements, or responses. So these are simply approaches we use to go and collect the facts or the evidence. You either observe, you count, you measure, or you get responses, maybe from a survey, and that is known as data. Then you now need to do something with that data. Now, what do we mean by statistics? Statistics with S is simply the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. So you collect data using the data collection techniques. For example, observation, using a questionnaire, using an experiment, you collect data. Now you need to organize that data and then analyze the data and then interpret the data in order to use it for decision making. Now, when we talk of population, it's simply the collection of all outcomes, responses, measurements, or counts that are of interest to you. So population is really what is of interest to you, but at times, because of time, you don't have enough time, you don't have, it's too expensive, you go with a sample which is a subset of the population. So there are times when you do the population. In that case, we'll call it a census, but most of the time we go with the sample. Now, generally, we are looking for a representative sample, and when we get the sample, we compute whatever we want from the sample, and then we do what we call inferential statistics. We go from the sample to the population, and we infer whatever we want. We'll have the opportunity to do that in class, and it's going to be really clear for everyone. So let's take an example. In a recent survey, 1,500 adults in the United States were asked if they thought there was solid evidence of global warming. 855 of the adults said yes. Identify the population and the sample. You can clearly see we do not look at all the adults, but only 1,500 of the adults. So we took a sample of 1,500 adults in the United States. Okay, now in order for us to describe it, so basically the population consists of the responses of all adults in the US. The sample consists of the 1,500 that we sampled, and in the responses we can simply say the data consists of 855 yes and 645 no's. That's it. Here we move on to what we mean by a parameter and a statistic. Let's take a look at some important words. So when we talk of a parameter, it's a numerical description of a population characteristic. For example, if you compute the average or the standard deviation from population data, you call that a parameter. On the other hand, if you compute it from a sample, the same average or standard deviation, you will call that a statistic without S. With S, you are talking of a field of study, statistics, but without S, it's simply a description of a sample characteristic. So in this example, you have to decide if it is a statistic or a parameter. In other words, you have to decide if you are dealing with the population or a sample. A recent survey. Survey is just a way of collecting data. You ask a question and you get the responses from people. So a recent survey of a sample of college career centers reported that, so it's already telling you a sample of college career centers. It's already giving you a hint. They reported that the average starting salary for petroleum engineering majors is blah, blah, blah. So you have to determine if this value, it's already the average. The average was computed. Is it from a sample or from a population? If it's from a population, you are talking of a parameter. If it's from a sample, then you are talking of a statistic. So it's a sample because it mentioned sample, so you are dealing with a statistic, and that's the value of the statistic. And of course, a sample is a subset of a population. It's supposed to be a representative sample. Now the next one says the 2,182 students who accepted admission offers to Northwestern University in 2009 have an average SAT score of 1442. So here you are looking at all the students who accepted admission offer, all of them, not a subset of them, but all the students who accepted admission offer. So you are given a particular, you are given the average SAT score. So here you are dealing with the average of data coming from a population. So you are dealing with a parameter. So we say population parameter. Now let's jump into something else. You have two main branches of statistics. You have descriptive statistics, whereby we organize data, we summarize it, and we display it. We are going to be doing a lot of it in this class, and especially using Excel. So we summarize and display it using tables, charts, and so on. On the other hand, inferential statistics, you are basically using sample data to draw conclusions about a population. So you've collected data on a representative sample of your population, you've computed maybe the sample mean, and then you are trying to find out what is likely going to be the population mean. You have your sample mean, you want to find out the population mean, or your sample average, you want to find out the population average. That's just what it's all about. You go from a sample to a population. Why do we generally take a sample? Because it's not as expensive as taking the whole population, and it's pretty fast. It doesn't take so much time as if you had to talk to the whole population. Okay, let's move on. So let's take these examples. We have to determine if we are dealing with descriptive statistic or we are dealing with inferential. So decide which part of the study represents the descriptive branch. Now, for you to know the descriptive branch, you just want to find out if they are just describing the data. But inferential, you want to find out if they are going from a sample to a population. That's the main idea. Okay, a large sample. Here you've already been told you are dealing with a sample. That's very important. A large sample of men aged 48 was studied for 18 years. For unmarried men, approximately 70% were alive at age 65. For married men, 90% were alive, blah, blah, blah. Okay, so let's just jump here. So you are dealing with descriptive statistics. It involves statements such as for unmarried men, blah, 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 this. So you've taken a sample and you've computed some things. So you are dealing with descriptive. Now, on the basis of the things you've computed for your sample, you can now infer something about the population. Here we are saying a possible inference drawn from the study is that being married is associated with a longer life for men. So you are saying, based on a sample, we can now generalize for the whole population by making such a general statement. Okay? However, we started by taking a look at descriptive statistics. Now, let's move on to something else. We want to take a look at the different types of data. You have qualitative and quantitative. Now, when you talk of qualitative data, you are looking at attributes, labels, something that is non-numerical or you cannot compute. Now, it's possible under qualitative to have a number which means nothing. For example, the number on the t-shirt of an athlete. It doesn't mean, so if you play soccer, to have number 5 doesn't mean you are 5 times better than others. It's just like your name on your shirt. That's it. So your major, your place of birth, your eye color, that's qualitative data. Now, on the other hand, quantitative data, you are talking of numbers and you're talking of numerical measurements or counts. You're talking of something where 0 really means absence of something. Okay. Now, your age, for example, the weight of a letter, the temperature, 0 really means something. So you have quantitative, you have qualitative. You can compute things on quantitative data, but qualitative, you can't really do any meaningful computation. Now let's take a look and see which one is qualitative, which one is quantitative. You can see immediately here you are looking at different brands, and on the other hand here you are looking at the retail price. You can clearly see you are dealing with quantitative and you are dealing with qualitative here. It's like the name. Okay, we'll continue with levels of measurement in the next video.